So let's do this example. Or I have a test example also, you can do that, right? So which is x to the 4 minus 3x squared plus 6x squared plus 2x. This is f of x. We need to find all zeros. This is given to us, and then we are also given 1 plus 3i is a 0 of f. 1 plus 3i is a 0 of f. So what does this mean? We know this is a 0 of f. They are given, 1 0 is given. So we know a fact. What is the fact that we know about complex zeros? What is the fact that we know about complex zeros? They come in conjugate pairs, right? So if 1 plus 3i is a 0, the conjugate of this is also a 0, right? So therefore we are going to say, therefore 1 minus 3i is also a 0 of f of x. Okay? So now we have two zeros. So we have two zeros means what? What does this mean? What is when we have two zeros, what do we say? Let's say, for an example, remember we say, if you have x squared plus 5x plus 6, if I say x is equal to negative 2 is a 0, if I say this is a 0, right? Is a 0, this means what? We know by the factor theorem, x minus 2 is a what? Is a what? Factor. We discussed this many times. We already know this. We use this many times. Okay? So this is a fact here that we are going to use here. We have two zeros. Now we are going to find factors because of using those two zeros. Okay? So what are the factors of? So we are going to do the same thing, guys. It's the same thing except we are using what? Complex zero, right? So now we are going to see x, therefore, because of this, therefore, I'm going to say therefore, these three dots means therefore, x minus 1 plus 3i, this whole thing is a factor, right? And x plus what? 1 plus 1 minus 3i can I say this? Are factors of f of x, right? Everybody agree? Everybody agree, right? Yes. Okay, so now what can we do? If if I say this, if I say x is equal to, if I say negative 2 and negative 3 are factors, are zeros of this f of x. If I say, if this is the f of x, negative 2 and negative 3 are factors, I can take each factor. If I say these are zeros, then I can say x minus 2 times x minus 3, like I can multiply the two factors, right?
Yes.
Because each of factors, I can remember when we have polynomial functions, we can write the polynomial in terms of product of factors, right? It's the same thing. So now we can say, because these are factors, then we can say x minus, I simplify this, 1 minus 3i times x minus 1 plus 3i. So I can say this is this product of these factors is also a factor of the basic polynomial that is given to us. Is a what? Factor of f of x, right? So we know that. So now what do we need to do? What do you need to do? Multiply these two. So let's multiply these two. X squared minus x minus 3i right? Minus x plus 1 minus 3i minus 3ix plus 3i minus 3i squared. We know how to find this. Now simplify this. Okay? Simplify this, what do you get? X squared. This is.
Why is it minus 9x squared?
Which one?
The last one.
3 times 3, 9. Very good. Okay, so this get cancelled. Plus 3i, these get cancelled. These two get cancelled, correct? These two get cancelled. And then this and this get cancelled. So always when we have conjugate, when we multiply conjugate pairs, they are going to get cancelled, the I is going to get cancelled, I squared is negative 1. So substitute negative 1 to I squared, we get x squared minus x is minus 2x. Minus 2x, that's going to be negative 1 I squared, substitute negative 1 for I squared, then we get plus 9. Are we good? Plus 9 plus 1. So what is all together? Plus 10.
So you can substitute I for negative 1?
Yes, that's what we do, right? Remember, you guys have done this. Negative 1 means I squared. This is negative 1. Negative 1 times. So this means this. Negative 1 times negative is positive. Okay? Okay, so now we have this. So this is little. Once you're familiar with this, the only thing is we are working with complex. And the other thing that you have to apply is once we know one complex factor, complex 0, then the conjugate of that complex 0 is also a 0. Okay? Okay, so now what do we need to do? So what is f of x? What is f of x? We know this whole thing is a factor. This whole thing is still a factor because multiplication of these two is a factor means this whole thing is a factor. Right? So what do you need to do now? We are going to divide the polynomial, given polynomial by this. Okay? To find the remaining factors because that's the third power one. So the third power one divide by this one. So what we have there? So I'm going to go here guys. So this is f of x. So f of x can be written as f of x is equal to what we have there is what? X squared minus 2x plus 10. This time, this is a factor because those two multiply, we get this. Times something else is also a factor, we don't know what this is. With an x, because this is x to the power 3, the last one supposed to be with an x, correct? So now what do we do? Now what do we need to do? How do you find what is this factor?
Divide.
Divide, very good. We divide this by this. Remember when we have done this many times, so you divide this by this. So what do you get here? X to the 3 minus 3x square. I wrote it wrong here. This is x to the 4. X to the 4 minus, here, plus 6x squared plus 2x minus 60 divided by what? How many factors are we expecting? Because our original one is x to the 4. Huh?
4.
How many? Another 2 with linear factors, 2 linear factors, right? So what is the other 2 linear factor? We need to divide this by what am I supposed to write here? X squared, this is going to be x to the 4, negative 2x to the 3, positive 10x squared. So you multiply this by this. We are thinking of, our objective is to get rid of this term. We draw a line. What do you need to do here? Subtract this part. So this is negative, negative become positive, positive become negative. You guys need to know real well how to do the long division. We went through this in class. So these get cancelled. Combine these two, what is it going to be? Negative x cubed. Combine these two, what is it? We can't combine like terms. Combine these two, what do you get?
Negative 4x squared.
What? We get negative 4x squared plus 2x minus 60. Now we need to get rid of this. What are we supposed to write here?
X.
Plus x?
Negative.
Negative x. So multiply. Negative x to the power 3, positive, what do you get?
2x squared.
Negative 10x. Are you good, class? Now we subtract, correct? This is going to be
Negative 2x squared.
negative, positive here.
Negative 6.
These get cancelled, right? What do we have here? Negative 6x
Yes.
plus 12x. All right.
Minus 6.
Minus. You guys are doing good here. Minus.
16.
We want to get rid of this. Minus 6. So now what do we get? So we have negative 6x squared plus 12x, and I'm going to bring this negative, these two we added, right? So here minus 60 also, I'm going to bring the minus 60 down here, and I'm going to multiply these two with negative 6, what do I get? negative 6x squared
12x plus 12x.
minus 12x.
Minus? No.
This times this is 12x.
Positive 12x.
Positive 12x. Negative times negative is positive 12x, yes. Positive 12x. This is negative 60. Negative 60.
Yes.
Okay? Now what do you need to do? Change the signs. Positive, negative. These get cancelled, these get cancelled, these get cancelled, so 0. So what does this mean? This whole thing is also a factor. So now we are good. So f of x, we can write this f of x can be written in terms of 4 factors. The 4 factors are linear factors. We don't want quadratic factors. Okay? We'll write as a linear factors. What's the first one? X minus 1 plus 3i. This is the first one. So this is like a bracket factor. The other one is, what's the other one?
X minus
X minus
1 minus 3.
1 minus 3i. Now, what the other quadratic factor we got is this. We know this is also a factor. Can we factor this?
Yeah.
So we know the last one is x squared minus x minus 6 is a factor. But see whether we need to factor this again. So you write this, if you factor this, what are the factors of this?
X.
Once you get a quadratic, you always know how to solve for x by using the quadratic formula, the worst case. Okay? Try using the factoring method first, and if nothing works, then use the quadratic formula to factor this. So what do you get? X minus 3, x
Plus 2.
plus 2. So there is a problem. We have to write all 4 factors. If it's a 4th degree, there's 4 factors. The polynomial can be written as. So this is how we are going to work with complex. Okay? When there's complex zeros. If, like this, if 3i is a factor, then 0, then from the theorem, negative 3i is also a 0, right? Same thing. So now you can say x minus 3i and this is x minus plus 3i, so you write like this, right? And x minus minus 3i. So now in this case, because it's just the 3i only, the a part is missing, this is easier. So x minus 3i is a factor here. This is minus minus become plus. X plus 3i is a factor. So now you can multiply these two. What do I get here? X squared minus 3i plus 3i get cancelled. Plus 9i squared. What is that going to be? X squared minus, this is minus 9. X squared minus 9 is a factor. Are you following me? Okay? You guys, are you okay?
Wait. That doesn't correlate to the problem.
Yeah, it doesn't go with what we just did. So-
This doesn't, no, this is a different problem. I'm
Oh,
just
what
saying.
is
This is a different problem. I'm just saying different problem. I'm just saying, I'm giving another example.
The errors.
I'm just giving another example. Okay? Sorry. This is a different problem. If 3i is a 0, then Negative 3i is also a 0. Here the a part is missing in the complex. Okay? So, you guys need to put away your cell phone. You can't put a cell phone on the desk, please. You have 3 here, right? Yes. Okay, so now what do you guys think? Can you do problem number, which one you said you're having?
Five?
See problem number 6. 4 is a 0, find the remaining 0. It's the same thing like I did here. Okay? And it's a 4th degree one. It's the same problem. But this is easier to multiply, so it's something like this. You guys see this? If 3i is a 0, if 4i is a 0, you have to say negative 4i is also 0. Okay? And then multiply the two factors, but you need to write the two factors as x minus 3i, x minus minus 3i. Because this is x minus plus 3i and x minus minus 3i, because those are factors. If a is a factor, x minus a is, if a is a 0, x minus a is a factor by the factor theorem. Okay, so do you guys see the similarity of this and this problem?
Yes.
It's the same problem. Okay, so any questions? And you all basically know the procedure. You basically know the procedure from before we did the other problems with this. The only difference is here you're working with a complex 0. Okay? Okay. So that, okay. Now this one is an easy problem. 4th degree polynomial having real zeros. Now this one is an easy one. I gave this problem. I know I didn't do an example similar to this, but I will do this problem. I will have a similar problem. Okay? So, okay guys, so let me. So what we have here, problem number 5. Problem number 5 on your practice case. There's a 4th degree polynomial, p of x. We don't know this 4th degree polynomial. Ax to the power 4 plus bx to the power 3 plus cx squared plus dx plus, this is a 4th degree polynomial. We don't know what are the values of a, b, c, d, e. We need to find the exact values. Find the polynomial. What is given to us? What is given to us, class? With real coefficients, these are real coefficients. What is given to us? They are given 3 zeros, right? What are the zeros? The zeros are given. Zeros are negative 3 is a 0, negative 3. and 2 plus I is a 0, are zeros. These are zeros. This is given to us, correct? Also, what is given?
Multiplicity.
Where negative 3, this 0 is a multiplicity 2. That means 2 of these are there. Remember we had the multiplicity 2, multiplicity 3. That means there are 2 factors, 2 of these. So we have x minus 3 and negative 3 and another negative 3. This comes in pairs, multiplicity 2. Okay, so now what we have here, because of this, so we know this comes in pairs. This is a 0 means what? This implies what? This is not given to us, but what we know from this?
2 minus I.
We know the theorem, we can apply the theorem and we can say
2 minus I.
2 minus I. Very good. 2 minus I is also a 0. You guys following this class? Okay. Alright. So we are good now. Now we know 4 zeros. How many zeros we are supposed to have for this polynomial? 4. If it's n degree, the most you can have is the n number of zeros. So, if n degree has n number of zeros, so we are going to write this p of x as, these are we can write as product of linear factors. We know the zeros, each one is a linear factor. So we are going to write x minus something, x minus another thing, x minus another thing, and x minus a. Can we do this? Yes, right? So now substitute. What's the first one you're going to say? What to say? Negative 3, like that. First one. And this one? Another negative 3. And this one?
2 plus I.
2 plus I. Put parentheses, class. You see, because this is, you need to subtract this whole thing. Okay? Your parentheses are important here. What is this one going to be?
2 minus I.
X minus I. Are we good? Now what do you need to do to this?
2 minus
All we need to do is simplify this. Just you guys know how to simplify this. So I'm not even going to. Okay? So simplify this 2, we get x plus 3 here. So we get x plus 3 times x plus 3. We get times, this is x minus 2 minus I times x minus x.
2 minus I.
Yeah.
It's 2 minus I.
The last one,
2 minus I.
and then the next one. It's,
Oh.
yeah.
So what do I get here? Minus 2 plus I. So just multiply all this. So this will become x squared plus 6x plus 9. And this become x squared minus 2x minus, plus 2I. Come on guys, help me out. What is it?
4I.
Minus 2x plus 4 minus 2I, and then multiply everything by negative I. Negative x, positive 2I minus I squared. Did we do this right?
Negative IX.
This and this get cancelled. What else?
Isn't there I?
I think it's negative IX.
Yeah.
The third to last.
Yeah, negative, if we multiply this by I,
So negative I times X is negative IX and plus
Yeah, this is negative I times x.
No, the second.
This one's supposed to be positive, right?
No, that one was right. The third to last term of the parentheses, like down.
Okay, x squared, negative 2x, positive 2xi, positive 2xi, this is x, this is xi, negative 2x, positive 4, negative 2i, multiply this by negative 2, then negative xi here,
Yeah.
negative xi, positive 2i and negative I square. Okay, so let's do this. Negative 2i,
So, xi, negative xi, and xi cancel out.
this and this get cancelled. What else we have? Positive 2i, I think
Yeah, this one.
negative 2i.
You have,
This is supposed to be positive 2i. Yeah, positive 2i, this get cancelled. Right? So what is remaining here? X squared plus 6x plus 9, this whole thing times
X squared
x squared
minus 4x
minus 4x
plus 5.
minus 4x, this and this combined
Plus 5.
plus 5. Yeah, but that's 1, right? That's positive 1, so plus 5, very good. Now we can factor this again. We are not, this problem they are not asking to write in terms of product of linear factors. What are they asking us? Find the polynomial. So then we don't have to factor this again, we are going to find the polynomial. So then you need to multiply these two and write the polynomial like that, okay? Okay guys, so yeah, so we are done with this. Okay. Any questions?
I cannot solve the seat number 6, the simplified.
This one?
Yeah, right here.
you can't get that big.
Let me look at this, okay? I'm going to give something that is equal to 0 here, okay? When you reduce this, let's see, when you reduce this, you get negative 4x squared. You're right. This part is right, right? That's positive 16, that's right. We divide this by this, 2x squared. 16x squared. 32x squared negative 80x. Let me look at this, okay? I'll look at this, I'll let you know. I'll do this problem, but I'm going to do it separately. I'm not going to take the class time. I'll do it, okay? Okay, so, okay guys, so, couple other things.
So should we, for 6, since the test is Thursday, should we try and do a different problem? Or is there other ones like that? I just want to make sure I know how to do it for the test.
You guys want me to do rational one? Rational fraction?
Oh,
We
no,
how many
first-
we did about 7 examples
Oh, no,
of,
I know rational, I'm talking about number 6, since you have to do it on your own time.
Number
But the
six.
test is Thursday, so I wanna make sure.
no, number 6, the test question is exactly like what we did,
In
okay?
class?
Class, similar, it will be something when you divide, it will get a 0,
Okay.
okay?
Just wanna make sure.
So if you are not getting a 0, maybe I made a mistake writing the polynomial function, okay? So, I'm going to check on that, okay? So I don't want to do the same problem again and, so it's very similar to this. If you can't do factor and get a 0 at the end when you, she did it right, x squared minus plus 16 is a factor. So now when you divide the bigger polynomial by x squared plus 16, you're supposed to get a 0 because you're supposed to write polynomial, okay? Polynomial in terms of product of linear factors, okay? So it's similar to what we did, but however, I'll check whether I made a mistake on writing the polynomial there. Question?
Because you said like x squared minus 9, like x squared plus 9x, so it'll turn into a 9, right? So it'll be x squared, like, okay, so like.
Because I squared is
Is 1.
negative 1.
Well, yeah, I squared is 1.
So this is,
But -1 squared would be 1.
It's still 1.
no, the I squared is
The whole
negative 1.
the whole I squared is negative.
Yeah, so this is supposed to be plus, you're right here. Oh, I'm sorry, this is supposed to be plus, so there's a mistake here. This is negative, negative, this is a negative when you multiply this. Now I squared is negative 1, so this becomes plus 9. Okay? So yeah, I made a mistake here. You guys see this? Sorry about that. When you multiply this, you get negative here, right? So the last factor is x squared plus 9. Okay guys, so look at what kind of problem you want me to do here
You do 4.
from the. You guys remember 3, right? We did this long time ago. How to solve the rational inequalities. So you remember this, making the chart and coming up with the solutions. So this we already did. This also we did on the first test. Okay. So this is, look at the notes there. If you have questions, you can ask me during the office hours time today. I'll do this problem for you. Okay, so because there's extra credit, I already gave this long time ago saying that I'm giving a similar test question like this, right? So this you should know how to do it. In case you don't know, this is very simple, you can do it, everybody can do this, you can ask me, okay? Okay, so number 4 we did a similar one. Number 4, so let me do number 4. I don't want to do this problem, but just fine, I'll do this problem. So what do you get? P of x is given to us, 2x to the power 4 minus 7x to the power 3 minus 8x squared plus 14x plus 8. So what do we need to do here? First,
All possible.
part A is all possible zeros. How will you find all possible zeros?
By the rational.
All rational root theorem. What's the rational root theorem says? Possible zeros are
P and Q.
possible zeros are P over Q, right? All possible zeros are P over Q. P is all the factors of.
8.
So this is A, 0, and this is what? Or we can take this P of P here, right? This is A, this is the leading coefficient, right? So this is AN, this is A0. This is the constant term. So we are going to divide the constant term by the leading coefficient. So we get 8 over 2. So we get plus or minus 1.
4 plus minus 8
8 divided by
plus minus 1 and plus minus 2
okay. So now what we get here?
plus minus 1
So this means you use this and this.
yeah
You use all four. Use this one.
1 plus minus 2 plus 4
4,
and plus minus
8 because you divide by this. Now you have to use 2.
8 yeah
So we get plus or minus
1 over
1/2. 2 divided by 2 is 1. We already have. 4 divided by 2 is 2. We already have.
yes
8 divided, we already have this,
Yes.
right?
Yes.
So we get plus or minus 1/2.
yes
Okay? Okay, so we get, this is all possible. Now, the next one is find the zeros of P of X. So we know we just have to look for possible. This is 4th degree one, right? So look for possible. Just you need to use trial and error and see. If, let's say if 2 is a factor. If 2 is a factor, what do we have here? Let's think 2 is a factor, positive 2. Then you take this polynomial, divide by positive 2, take this polynomial and divide by positive 2, right? And then we are supposed to get a 0. If we don't get a 0, remain a 0, then it's not a factor. So we are going to do synthetic division really fast, okay? Do synthetic division really fast. So which one you are thinking that it's going to be? If you use 2, is it going to be good?
no
2 will not give you a 0. How about 1?
no
1 will not give you a 0? Sometimes you will be lucky, you will get a 0 as a remainder really fast. Sometimes you have to try 2, 3 up there. Okay? How about 4?
yes
4 will be, so let's check here. Check whether for each one x equal to 4. So we take 2. So we need to make sure that write this in ascending order. So what do we have?
2 minus 7 minus 8 plus
Is it in ascending order? You guys know what I'm talking about, right? And then we need to write 2 here, 4 here.
Yeah.
So this becomes positive 8. So what do you get here? 1. This is 4. Negative 4.
Yeah, you can see.
yeah we can have 0
This is
0 minus 16
minus 16.
and
Minus 16.
4 times 4 is minus 16.
Then you get negative 2.
And then 8, yeah. So, I'm just rushing here and I'm like getting blank sometimes here. Okay, so what happened here? X minus 4 is a factor, right? 4 is a 0, right? So x minus 4 is a factor. This is a factor.
yeah
Yeah.
and
When this is a factor, we need to take the opposite of this, right?
yeah and other one is minus 1
Okay, so now we know this is, so now the remaining is what? X minus, we know x minus 4 is a factor, we got a 0, so now the remaining polynomial is
So that's
2x to the 3
plus x squared
plus x squared
minus 4x
minus 4x
minus
minus 2. So this is what? Now we have a third degree. So this is x minus 4 times, we have a third degree. What do you need to do to this?
divide.
So we are going to use another rational 0 here, possible 0 to this. Okay, so you're doing it twice here. Okay, class? What's another rational zero to this?
Enough time to do all this.
These are all possible ones. Use another one. 1. So we take this 2, 1, -4, -2 and divide this by will 1 give us a 0? 1 will not give us a 0. We know 2 didn't give us, 4 didn't give us. Let's look with 1/2.
Minus.
Minus 1/2. If positive doesn't give us, so let's do with the negative of this. That means let's x minus minus 1/2 is a factor. Okay, this is a 0. Okay,
You will be there.
so what do we get here?
2.
Multiply by negative 1/2,
Negative 1. 0.
multiply by
0.
negative 1/2, 0.
Minus 4.
Multiplied by negative, negative become positive, positive 2. Yeah, good. Okay? So this is a factor, this is a factor, this is a 0, the negative of it, right? X plus is a factor. So what do we have here now? X minus, minus half, okay?
2x. Or
Now we are going to rewrite this as what? 1 degree less this one, third degree, 1 degree less is
2x squared.
2x squared. X term is
0.
minus 4. That's it, right? We can factor this. Factor 2 out. So x minus 4, this become x plus 1/2. Factor 2 out here, so you can put that 2 here. And this become x squared minus 2. I put the 2 here. Factor this. Factor this, what do you get? So this is like matter of doing trial and error, P over Q. Make sure not to reduce here, okay? All the factors of P divided by all the factors of Q. Okay, so this one, what do you get? X minus 4, so 2 times x minus 4, x plus 1/2, and then this x minus square root of 2 and x plus square root of 2. If you do the quadratic formula for this, you get minus square root of 2 and plus square root of 2 are zeros, okay? So this is P of x in factor form. The one that you get on the test, I'll make sure it will easier one than this, okay? You guys did this on the review part also. Oh, this is okay.
So for the second time you do the synthetic division, for all the possible zeros, do you use the ones from the original polynomial or do you use,
Yeah, the original polynomial.
so you wouldn't,
Yeah, this is all possible in the original. We don't have to do the next, you can do the next one also, but you don't have to.
but then if you do the next one, would it like narrow it
It will be
down?
narrowing, yes.
So then it would kind of maybe.
Yeah, yeah. You don't, it's not asking, see, one of these will be, yeah, it will-
So
good
technically one
thinking.
of those could.
Yeah,
Okay.
if you do all possible to this one, it will narrow down, yeah,
Okay.
your possibilities of checking, okay? Yeah, but that's another way to do it, you can think of that. Okay guys, so any other question? So you guys are comfortable doing these problems? You want me to do the rational one is, which one? Number 7 we did so many times this. I think we spent a lot of time on this. F composition G and G composition. You guys did this on the quiz also. G composition F. I'm not asking you to prove that they are inverse of each other. Okay? So, this one, number 8 guys, number 8 I need to actually go through something really fast here, number 8. I have 5 minutes, 10 minutes actually, number 8. We know f of x, let's say f of x we have f of x equal to f of x given 2, 3, 4, 5, 6, 7, 8, 9. This is f of x. What's the domain of this? Domain of this function? If you have all ordered pairs, I'm just like reminding you guys something. What's the domain?
2, 4, 6.
This is f of x is given in terms of a ordered pairs, right? So in this case, the domain is 2, 4, 6, and 8. What's the range here?
3, 5, 7, and 9.
3, 5, 7, and 9. So we know the domain and range. We also know that we discussed this when we did the inverse function. Now if I take the f inverse, I look at this and I write f inverse of x. What's f inverse of x? What do I need to do? What do I need to do to find the f inverse of x? Switch, right? 3, 2, 5, 4. So write this. This will like clear some of the 9, 8, right? Isn't this the domain? I mean, f inverse of x, right? Now what's the domain of this function? 3, 5, 7, and 9, right? What's the range of this function? 2, 4, 6, 8. Now do you guys see, what can you conclude from this? When you find the f inverse, right? The domain and range, they switch, correct? Domain of this is the range of this. So if I can ask the range of another function, all I have to know is find the domain of this, right? So now look at this question is asking me to find, so number f of x is equal to 2x plus 1 over x minus 1. So what do I have to do here?
F of x equals y.
F of x is y. We need to find f inverse, right? So we are finding f inverse. Y is equal to 2x plus 1 over x minus 1. Now switch, correct? X is equal to 2y plus 1 over
1.
y minus 1. Now what do I have here?
Multiply y minus 1 on both sides.
Yeah, multiply by y minus 1 on both sides. X times y minus x, just cross multiply this, is equal to 2y plus 1. Now we have to solve for y, right? So xy minus 2y is equal to 1 plus x. Now factor y out, x minus 2, 1 plus x, divide both sides by, right? So these two, these get cancelled. So y is equal to 1 plus x over
X minus
x minus 2. Now this y means f inverse x is equal to 1 plus x over. Are you guys okay with this class? Okay. Now what you need to do is, you want to find what this asking is. What is this asking? Let me see.
Range of x. Range.
Find the range of f of x. Remember the first one, when the first test I gave you to find the range, I mean it was hard for you to find the range, right? Because some functions it's hard for us to find the range. Remember, some functions, the domain, we already know how to find the domain of any function, right? How to exclude the numbers that are not giving us a real number, right? So when you substitute to evaluate the function value, right? Now, and this one is asking find the range of this function. It's only asking to find the range. Part B is find the range of the original function. In order to find the range of original function, what do we have to do now? Find the domain of the inverse function. Do you guys see that? Find the domain. That's what it says. Use your answer. Use your answer from part A to find the domain. So what is your answer here? Answer is f inverse of x is equal to what here? What do we have?
1 plus x over x minus
X plus 2, that's right? Okay. So this is the f inverse of x, right?
x minus 2. It's supposed to be x minus 2.
Yeah, x minus 2.
Gosh, where are we?
Like,
Oh,
you just, it's just in the answer. You did it right.
Okay. Rushing guys, so this is this. Okay, so now what we have to do? Do you see the pattern here, right? So I'm always doing you guys a smaller illustration so you can remember. This is like, in every time now we have a huge functions, they are asking to find the range of that function. All you have to find the domain of the inverse function, right? Now remember, not all functions, this is kind of tricky. I'm not going to give you the inverse function has to be a function, okay? Not all functions has inverse of all functions are functions. Only inverse of one-to-one functions are functions. But I'm not going to give a question like this. I'm going to give this. This is also a function. This is remember they have to be functions. Inverse, original function is a function. And in this case, it happened that the inverse is also function. Okay? Some cases the inverse is not a function. If it's not a function, its domain is we have to. Now I'm not going to give a tricky question like that. Why this inverse is a function? Because the original function is one-to-one function. Okay? So here we know. Now, so here we know that this is a function. Inverse is also a function, right? Now therefore, what is the range here? Range of f of x, range of f of x. We need to find the range of f of x. This is the question. We are going to use this answer. What's the domain here? Right, the domain of this. Domain of this is all x's are good except x equal to 2. So what is it? Negative infinity to 2, open, x equal to 2 we can't use, union, 2 to infinity close. So this is the domain of this function, which becomes the range of f of x. This is f inverse of x, remember? So the range of f of x, the range of f of x is this one, domain of f inverse of x. You guys see that? So all you have to do is find the domain of f inverse of x. So you need to look at f inverse of x. I mean, you need to find f inverse of x. You get some points by finding f inverse of x here. Okay? You do get points for finding. So use that answer. So all you have to do is remember what? What do you have to remember? domain of f inverse of x is the range of f of x. Because we know that from here. If you work with numbers, we know that. Domain range, we change. We switch the x numbers with y and y numbers with x. Okay? So therefore, so the answer to this is range of f of x is the domain of this. So the answer to this is negative infinity to 2, union 2 to infinity. Okay? Is that everybody following this? Understood? I plan to do a couple of other problems from here, but this is what it is. I'm always rushing here. Okay, so if you need help with number 3, if you need help with number, which one? Number 9 is okay. Number 9 is, number 9 is which one? This is the same as, you guys did a quiz problem on this, okay? I did tell you guys I'm covering something like this on the test and the quiz long time ago, right? So this one is easy, okay? So this is like basic standard exam, okay? I'm not making it very easy, I'm not making it very difficult, but this is, I gave you enough problem for you guys to see, right? I gave you long time ago, long time ago, about 3 weeks ago now, right? So I gave you sample questions and I'm giving you a practice test. I'm here after class for you to get help.